Good evening, everyone, and welcome to Sky Observers Hangout. Hello, my name is Michelle, and I'm the Director of Public Observing at the Adler Planetarium in Chicago, and I have a friend joining me tonight, and my friend is...
Me! Sorry, I would do that every time. My name is Adriana, and I am the astronomy educator at the Adler. We've got some other friends with us behind the scenes tonight, too. Our YouTube chat moderator is Colleen, and answering questions in the chat is our astronomer friend, Geza. So if you see the Adler's name highlighted in yellow, that's Colleen, and when you see a name with a blue wrench next to it in the chat, that is Geza, helping us by answering your questions and comments. So feel free to ask away.
Now, you may have noticed, if you're a fan of Sky Observers Hangout and you've joined us before, you may have noticed that I am actually in the front room of my house. We are not at the Doan Observatory this evening, and there is a really good reason. It should come as no surprise to most of the country right now, who is being hit by a giant snowstorm, and it is currently snowing like you wouldn't believe on Chicago's lakefront right now. So it is not safe for us to be at the observatory tonight. Forgive us for that, but we are prepared with images and video and all sorts of fun stuff. So forgive us for that. We called it live from the Doan Observatory. We really wanted to be there tonight, but Chicago's weather took over. So anyway, we hope you enjoy the show tonight. Now, Sky Observers Hangout is a place for us to gather together to nerd out about the sky. And our goal is to give you practical tips and useful information about all things related to sky observing. If you want to just watch the show, that is perfectly fine. We also would love to see your questions and comments in the YouTube chat. So feel free to interact with us and with each other.
Yes, we genuinely love hearing from you guys. So to get this show started, if you haven't already, tell us in the chat where you are tuning in from. And as an added bonus tonight, since we're talking all about our observatory, tell us, have you been in an observatory before or looked through a really big telescope before? And if so, where was it?
Cool. That'd be cool information to find out. So while you're doing that, while the Adler's doors must remain closed, we are doing our very best to keep our virtual doors open by creating and sharing some out of this world content for you. If you wouldn't mind, use the link that Colleen is going to put into the chat in just a sec to donate what you feel comfortable to contribute to our programming. Thank you so much for allowing us to share our universe with you.
Yes. And you can always help us get more visibility for our shows by hitting subscribe for the Adler Planetarium's YouTube channel right below this video. If you like us, you can give us a thumbs up too. We'd also like to say a special thank you to our sponsors tonight, Bank of America and CNA. We have an astronomical amount of appreciation for you. Seriously, you guys are stellar. Okay.
That is so good. If this is your first time for Sky Observers Hangout, Adriana is the queen of the astronomical puns and phrases. So hats off to Adriana for that. So okay.
All right.
Go ahead.
So let's check in to see where you guys are tuning in from and see if you guys have shared about being in an observatory before. So we've got some old friends. Steve Cosgrove says, "Happy whiteout, same to you." Excellent. We've got Brent and Avery from Maryland.
Hi, Brent and Avery. Great to see you in the chat again. Awesome.
Great to see you again. Gregory from River Forest. Eric from Elgin. Megan from Eugene, Oregon. Oh, we've got Kate Z says that they were able to go to look through the telescope at the Doan Observatory. Very cool.
Awesome. Very awesome.
We hope to see you again sometime.
Yes, I saw a name go by, Michael from Oklahoma City. Michael, I know you're getting some pretty nasty weather. You did down there today, so hope you guys are staying safe down there.
Yeah, absolutely. All right. Well, thank you guys all for joining us.
All right.
Oh, Rich has been to Yerkes. I also went to Yerkes and got to look through that telescope. It was one of the most exciting things that's ever happened. Okay.
And it's really fun to see that folks have been to observatories before, but if you haven't, we're happy to share our observatory with you. So we are so glad you're all here with us. Now, let's get to the show. It probably won't come as a surprise to anyone as a surprise to anyone, that Chicago's weather is not always the best for observing. We make do with what we have, but sometimes what we've got is a lot of snow or a lot of cold, or both in this case. And so tonight we've got all of the above. And because of course we do. Of course we do. Of course it's the middle of February, and yes, we had all this happen to us. But because of that,
Classic
like
Chicago.
we said, yeah, it's Chicago. But because of that, for those who are just joining us, we are not in the observatory tonight, just not safe to be there. But do not panic. We knew this was a possibility and took plenty of images and video from the observatory to share with you tonight. So we hope you enjoyed that.
Yes, we sure did. So if you ever wondered what it would be like to run an astronomical observatory, we've got you covered. First things first, though, Michelle, for folks who don't know, what is an observatory?
An observatory, well, let me show you a picture of what an observatory looks like. And this is our observatory.
Great place to start.
Yeah, an observatory is just a building with a telescope for observing the sky. Nothing fancy, just your usual.
Right. And what is so special about the Doan Observatory in particular?
So we're very proud of the Doan Observatory. It has the biggest telescope in the Chicagoland area for public observing. So there are amateurs out there that have some big telescopes, but ours is available for the public to come and see in non-pandemic times, of course. It's located in Chicago on the shores of Lake Michigan, just behind the Adler Planetarium. And we've got a new telescope inside the observatory that was installed last year. It is a 24-inch telescope, and it was replacing a 20-inch telescope that we previously had in the observatory. So for many of you, this may be the first time you've actually seen a picture of our brand new telescope.
Yes, super exciting. So with telescopes, size is important. That measurement that you're hearing, 20 inches, 24 inches, is how wide the main telescope mirror is. The main telescope mirror's job is to get as much light as possible to your eye so that you can see even faint objects more brightly and with more detail. So bigger mirrors reflect more light to your eye, so a bigger telescope generally gets you a better view and helps you see fainter objects.
And we can show you a picture of the big mirror inside the telescope. So there it is. Isn't that cool? It's so clean. I was just there a couple weeks ago. It's still this clean. It's really great. Not that I'm excited or anything, but we can also explain how it works, because just showing you a picture of the mirror, that's one thing, but how does this thing actually work? So light comes into the telescope in this picture from the top, from the other end, and it comes and hits the mirror at the back. That mirror is curved, and that light gets reflected back to a smaller mirror close to where the light entered, and which sends the light through a hole in the first mirror all the way to the other end of the telescope again. And that's where you would put your eye or a camera. That means all the light that's shown onto the mirror gets condensed down to fit your eye. So looking through this telescope is kind of like having a giant 24-inch wide eyeball. Let's all think about that for a second.
I love that image.
All right, go ahead.
All right. So because we're talking about our Chicago Observatory, I do want to mention a lot of folks are aware that Chicago has some pretty bad light pollution. So you might be wondering, is Chicago a bad place for an observatory? And to answer you before you ask it, not at all. Now, I'm going to be honest with you. It's not the best place for an observatory. Of course, so that would be in space or in a darker, drier place. But a lot of people think that light pollution just means that you can't observe anything or take any kind of data, and those folks are wrong. You can still do a lot of really cool observing from the city. You can observe really bright objects pretty well, even with light pollution, and dimmer objects can still be captured with longer exposures to collect more light, and you can use image processing to stack many dimmer shots together into one brighter, more detailed image. So you'll see what we mean when we share images from the observatory with you in just a little bit. For now, Michelle, let's talk a little bit more about our telescope. How do you move such a big telescope to point it?
Well, I'm going to actually show you that. So let's take a look. I'm going to share the screen, and that's going to be the image we just showed, which is the light path. But I want to make sure that you get to see the video starting at the right spot. So here we go. There we go. So it'll come up in just a second. So the whole thing is moved by motors. It's by gears. It's huge and somewhat heavy, but it is very well balanced. Now, balancing the telescope was part of getting it installed here. The goal was to make it balanced enough so that the system didn't have to work too hard to move it. It's so well balanced that we can move it with literally just a slight push. And I'm going to start this video again so you can actually see it. And there we go. So literally, when everything is off, I can move the whole thing by pressing it with one finger. It's really, really amazing. So there we go. And the proper way to move it is to select a target and to let the computer do the work. So, whoops, did I
No,
put it
that's
on the
perfect.
right
You can
video?
see the
Is that
telescope
good?
moving there. Yeah.
Excellent. There we go. So what we do is we click on the star map on the screen, and then the telescope actually moves. It's really that simple. You click on the screen, and there's me when I was there a few weeks ago, and the telescope moves. The computer and the telescope are synced, so the computer knows exactly where to point it to find the object we selected. And one thing I want to mention that is really amazing is how quiet this telescope is too. It makes no noise whatsoever. It's really, really neat. So, all right, shall I go on?
Yes.
All right.
Excellent. So once we've pointed it, we can either look through the eyepiece, which is where you actually just put your eye on the telescope, or have a camera take images of what we're seeing. What you're seeing here in this slide, in this little video, is what we call an instrument selector. It allows us to choose either the camera or the eyepiece and easily change from one to another. So that'll help us out if we're taking pictures for part of the night and wanting to do actual observing with our eyes for part of the night. We can swap back and forth between the two. We can move. Oh, Michelle, I'm going to ask you a question. Okay, yes. There we go.
Yep, go ahead.
But here's a question. How does the telescope see through the roof out to the actual sky?
So probably notice. Yeah, of course, we got a roof in the way. What the heck do we do there? By the way, one thing I want to mention, part of this video, it isn't totally apparent from the video, is where do you actually put your eyeball? In this particular case, the eyepiece, so that's my finger right there, and the instrument selector, when it got to number 3, that's where we put the eyepiece into that section right there. But this instrument selector, we can put up to 3 eyepiece, 3 or 4 eyepieces, cameras, whatever. But in this particular case, the eyepiece goes where that part is for number 3. That's where that is. There's a little mirror on the inside, and it just turns the light to whatever direction we want to be able to see. So there we go. Pretty cool stuff. It means we can keep the cameras permanently attached if we want to. All right, so we want to go on to how in the world we move and move the roof in order to actually see out the roof. There we go. So the observatory has a slit that opens wide enough to point the telescope through. Observatory roofs also rotate to change the direction of that slit or that opening so the telescope can see through it to any part of the sky. Now we've got the video playing right now. So these are the windscreens that are covering the dome opening. All right. So we have to open the windscreens to be able to see the slit right there. There it is. And then we would open the roof in order to then look out that shutter opening right there. So we always warn people when we move the roof because it's pretty loud. We don't want people to get totally startled. Most folks aren't used to the roof over them suddenly opening and loudly rotating. So it can be a little off-putting. So anyway, those are our windscreens. And then those shutters open from side to side. There you go.
Excellent.
It's really It's really cool to see it at night too.
Yeah. I'm going to go ahead and check in on some of these questions that we're getting, Michelle.
Sure.
We've got a bunch of questions. Well, two questions about the Coronado, the H Alpha telescope. So that's a telescope that we have specifically for solar viewing that we used to have in the observatory attached to our 20-inch telescope. People are asking if we are planning on attaching it again. The answer is no.
Correct. Yeah.
We'll let Michelle finish that.
Yeah. So the reason for that is, and I'll let this play and then I'll stop sharing. So there we go. All right. So the reason is that this telescope, the manufacturer strongly recommends that we do not let concentrated sunlight fall onto the telescope mirror. And we don't even want to take the chance at doing it, because if the Coronado, if that solar telescope is attached to the same system as the big telescope, that means when the little one is pointing at the sun, the big one is pointing at the sun, and we didn't want to take any chance whatsoever with that. So no, we are not going to reinstall the Coronado solar telescope onto the 20-inch telescope or the 24-inch telescope system. However, the Coronado telescope is right there. It is currently on a mount that we can move, and so, well, right now it's sitting there, it's not moving, but we do have the ability to move it, and so we will be able to use it outside with folks to be able to look at the sun and all that. We just won't put it with the observatory itself, or onto the same mount as the telescope, as the big telescope, that is.
Great. So Michelle, what will become of the old dome telescope?
So we are currently looking for a home for it. We have it in storage. It is safe. It is crated up in lots and lots of big giant crates. It is offsite in storage, and we are currently seeking out a partner organization who would want to take it. So we're not selling it or anything. We're giving it to a partner organization. So we've had some discussions. Can't go into any details with that, but we've had some discussions. So we'll see where that goes. The pandemic has put a bit of a break on any of those discussions. So we're not in any hurry. It'll still be totally fine just sitting in those crates. But know that we are potentially going to find a new home for it.
Yeah. Is there a CCD camera that we're able to easily connect up to the scope? We have a few.
Oh, yes, we do. Should I go grab one of those cameras? Do you want me to go grab one? It's behind me.
Sure, if you've got it. Yeah, why not?
I do. So hold tight. Talk amongst yourselves for just a second. Actually, I'll just keep talking and you'll be able to hear me. And I'm going over here. You. Yes, you can. And here it is. And there we go. And so one cool thing about that instrument selector is it can handle lots of different cameras. And so the camera that I used to take some of the images that you're going to see tonight was this one right here. And so what I did was basically just slid it into the instrument selector where the eyepiece goes, tighten down the little screws, away we go. Simple as that. And then you plug this. In this case, I plugged it into my laptop, the one that I'm using to do the show. Just did that and took pictures. We literally can have this telescope up and running in about 5 minutes. It's pretty crazy. It's really cool. So yeah.
Related to that, Tim Dorr asks, how would you compare the operating software for the new 24-inch to the software for the old 20-inch? It's faster.
It's way faster. And this telescope actually knows where it is. So for those who don't know, so the last telescope, it's a great telescope. It really is. But the system that it used to be able to find things in the sky, the first thing that you had to do to use it at night was tell it what you were looking at. And so it could then do all the rest of the calculations from that, no problem. But you had to start with something that you could identify, like the moon or a planet or something like that. Or we would just find something, identify it, and then the telescope could do all the rest. And then you could click on the screen to be able to use it. This one, we're click open, enable a couple of motors, click away. That's it. It's really all it is. It's remarkable how versatile this system is.
Right. So let's see. Sid, age 5, asks the question, how many telescopes do you have in your house, Michelle?
4. Adriana, ask me how many are mine.
How many are yours?
1. The rest of them belong to the Adler Planetarium. We've been working from home since March. And so at the beginning of the pandemic, we brought home several pieces of equipment. So my dining room table is now the home of 3 cameras, 2 cases full of equipment. My front room has 3 more telescopes in it. So yeah, we have a lot of bits of the universe all over my front room.
Right. And I see that this is a PlaneWave 24. Which model is it exactly? What was the cost?
It was the CDK, the corrected Dahl-Kirkham, and the 24-inch, and so it's CDK 24, and the mount was the L500. L as in it's an L-shaped mount. And 500, the higher the number goes, the more weight the telescope can handle, or the more weight, sorry, the mount can handle. How much did it cost? It was approximately $100,000. I may be off by like 10,000, but it was about that much. That pretty much included installation too. Might be a little bit off for there, but that's it. You get the ballpark for the amount.
Cool. And let's do one more from this bit. Can you tell me the specs of the camera and what make it is really quickly, Michelle?
Yes, it is the Malincam Skyraider D as in dog, S as in Sam 2.3 plus. So Skyraider DS 2.3 plus. And it's a color camera. So we didn't have to put any color filters on it or anything like that. I mean, you can, but for this one, it takes color images. So we're going to show some images we took with that camera.
Yes. And leading into that, Kate asks, have you thought about broadcasting images from the telescope live on YouTube? Have we?
Oh.
In fact, that was our plan for this very evening, but the weather has not cooperated. So do not worry. We are talking about all of these cameras and how we can get these cameras set up to the telescope. And we have been doing that so that we still have images to share from this new telescope as well as previously taken in the observatory. So we've got a lot of stuff to show you tonight. And I'm going to use that to go ahead and segue right into it.
Go for it.
So what kind of images are we looking at tonight, Michelle? Is it stars? Is it aliens? Is it Jodie Foster making first contact near Vega? Is it Matt Damon growing potatoes on Mars?
It's all the above. No, probably not Jodie Foster or Matt Damon. We would love to see those stars, but no, we don't see those stars. But we have some pretty exciting stuff. We've got images of the Orion Nebula, Mars, the moon, and some galaxies.
Yes. Exciting. Let's take a look.
All right. So let me go to the first set of slides. So hold on. I'm getting there. All right. There we go. All right, we're going to start with images taken by our new 24-inch telescope, and we're starting with images of objects we might have been able to see tonight had the bad weather not put the kibosh on that. And we will start specifically with a place in space we've talked about before, and this is the Orion Nebula. Woo!
Yay! This is one of my favorite things to observe. All right, so the Orion Nebula is about 1,500 light years away. It is the closest large star-forming region to the Earth. Baby stars are born here, which is, I think, the cutest way to say that. So the 4 bright stars that you see in the middle of the picture on the right, those stars are called the trapezium. The gas in the nebula is energized by light from the bright stars, and then that gas emits the light that we see. So we've put two pictures side by side here, one with the brightness way up so that you can better see the gas in the nebula, that's the one on the left, and one with the brightness turned down so that you can see those really bright stars of the trapezium that are overexposed in the image on the left. So that's why you don't see those stars in the image on the left.
And I just want to reiterate to folks, this picture on the left was one picture. This is not a stacked image or anything. This is one shot, 5 seconds long. That's it.
Yes.
The picture on the right was one shot, about a second long, maybe two. No, it's actually about a second long. That's it. That's all this is, one shot.
Right.
And
so if we were doing data processing, we could manage having all of these things show up in one image a little bit better, but these photos are unprocessed.
Exactly. Highly unprocessed. And Adriana, can I tell them about the pink stuff in the picture? Can I tell them? I know it isn't
sure.
in our plan, but
no, go for it.
The pink that you see in the left-hand image, that's real. That is glowing hydrogen gas. I was floored when I saw this show up in a 5 second long picture. And it just amazed me that this was as good as it was. And this is the real glowing hydrogen gas in the Orion Nebula. So it was just great. I love this.
Excellent.
All right. Want to go to something new?
Yeah, let's do it.
All right. Let's go to video. There we go. Coming up. There we go. Okay. We've
got a little dot.
We've got a little tiny dot, and it is not exciting. It's okay. That's the point. So Mars, depending on where Earth and Mars are in their orbits, it could be anywhere from a 3-minute time delay to a 22-minute time delay to get between Earth and Mars in their orbits. Now, Mars is a bit reddish. You can kind of see that a little bit in this video.
Orange red.
Yep, there's a bit of an orange tint to it. So that Mars dust has the mineral hematite in it, and hematite dust is red-orange colored like rust is red-orange colored, making the planet look kind of that red-orange color to us. Now we're using video for our image here, and it's going to be very shaky. The seeing was not good at all the night that I took these images. There was a lot of movement in the air due to temperature. And those temperature fluctuations in the atmosphere can make astronomical images really blurry because the light has to pass through a lot of air in order to get to us. It's kind of like looking at your hand under a pool of water. The movement of the water distorts the image of your hand. The movement of the air distorts the image of whatever it is you're looking at through the telescope. Air can do the same thing. That's why this image of Mars is as shaky as it is.
Yes.
And it's also small because Earth and Mars were like 100 million miles apart when we took this picture, or this set of videos. So it makes total sense as to why exactly it is not impressive, because it's far and the seeing was terrible. But the fact we got it at all, that's cool.
Yeah,
all right,
absolutely.
Want me to go on?
Yeah, something pretty similar happening with our next image from a little bit further out in the solar system. Oh, while I chat about this, Michelle, Steve Cosgrove asks, can you show the blue snowball too? I know that's not in our original plan, but I don't know if you have easily accessible pictures about that.
I do. So
excuse me.
Just let me know when you want me to. I can stop sharing. I'll go grab it and then I can share that image. But yes, I do have that image handy because I had a feeling someone might ask about some pictures that we might not show. So okay, go ahead.
Okay, we will show it. But let's get to what we're seeing here for the time being. We have a little blue dot, kind of like Mars, but now it's blue. This is actually Uranus. So between 2 to 3 light hours from Earth, depending on where the planets are in their orbits, that kind of light blue color that you're seeing happens because there's methane gas in the atmosphere that absorbs red light, and that's what makes it this shade of blue. Uranus blue is one of my favorite colors. My couch is actually this color. That's not important for anybody to know, but Michelle can confirm.
I can confirm. Her couch really is that color. It's the coolest color couch anywhere. So
I will forever call it Uranus blue. And now we've got my favorite thing to observe in the sky next.
That would be the moon.
The moon.
So 1.3 light seconds from Earth. It is a much closer neighbor. The seeing this night was also not great, but there is a lot to notice about this image of the moon. So craters. Craters are due to impacts from objects in the solar system. As the moon moves through space, it gets in the way of pieces of asteroids moving through the solar system. They meet up pretty violently. And those pieces of asteroids impact the moon. On Earth, smaller objects on a collision course will burn up in the atmosphere before making it to the ground. The moon does not have an atmosphere, so smaller objects can more easily make an impact. And the moon's lack of an atmosphere also means there isn't any weather like rain or wind to erode or wash away impact craters like on Earth. So older impact craters are still easily visible. What then erodes craters over long periods of time is tiny micrometeor impacts, itty bitty little impacts, as well as ejecta from other impacts being thrown over the impact craters, kind of like a dust blanket. And then in this one, you can see peaks inside those couple of craters, especially the two on the right-hand side. Yep. So some of the craters have little peaks in their centers, and when a larger object impacts the moon, material gets pushed downward during the impact, and rock underneath will behave like a fluid. This material moves outward, and as the ground rebounds back upward, a peak forms in the center of the crater. I imagine it like dropping something in water or milk, and the impact pushes the water upward and outward, and then gravity pulls it back down, rapidly causing a rebound drop of water to splash up in the middle.
Excellent. Somebody asks, can you see landers or rovers on the moon or Mars from our 24-inch telescope? I'm so sorry to disappoint you. No, it is still too small. So the telescope can do a lot, but these things are still just far away. So it's pretty difficult to get that much detail in an image.
Not even the Hubble Space Telescope nor anything that we have on the ground from Earth can see any of those landing sites. So we've got a spacecraft in orbit around the moon called the Lunar Reconnaissance Orbiter, and the Lunar Reconnaissance Orbiter has been able to image those landing sites. So you have to be a lot closer, and you have to have a much bigger instrument to be able to have a chance of seeing anything like that. Okay, do you want me to go grab Blue Snowball? You want me to do that?
Yes, and while you do, I will mention to folks what will be happening for our next series of pictures. So we're going to show some additional pictures from the previous telescope, the 20-inch telescope. Before we get into these, I just want to clarify one more time. Due to the pandemic, we've had a lot less time with this new telescope than we would have liked. And because of that, we've had less time to get and process images with this new telescope. So processing astronomical images allows us to make dimmer objects look brighter and show a little bit more detail by stacking lots of images onto each other. The images that you just saw were unedited. But as we get more time with the new telescope, we'll be able to take and process much more detailed images. For now, we do have some older images from the 20-inch telescope that have been processed and edited to show lots more details. So we're going to show you guys those as well tonight. But Michelle still has a few more exciting things from the 24-inch, right?
Yep, that's right. So also to give people a sense of how much the pandemic has affected how much we can be with the telescope, we literally have been able to use this telescope 3 times. 3. That's it. Once in August, once in October, and once about 3 weeks ago. That's it. So forgive us for not having vast amounts of images, but I'm just so tickled that we can show you what we've got, because this just will give you a sense of what's coming. And here is the Blue Snowball. And so the Blue Snowball.
What is the Blue Snowball?
So the Blue Snowball is a nebula. It is a it's a glowing gas cloud, and you can see it. I mean, it really is blue. I did not colorize these pictures or anything. It really does look like that. And so it's just so cool. Anyway, so and let me see. I wonder if there was anything else. I'm checking the pictures to see if there was anything else cool that we got
No
that night.
problem. You can go ahead and do
Um,
that. We did get, let's see if we've got questions here. Were these photos taken with the Mallancam 2.3 Plus? Somebody
yes,
asks.
yes, yep,
Great.
absolutely. Everything was taken with the exact same camera. Okay, let me go to. Hang on. Oh,
Ronald
pressure.
Davis asks, where can I find this blue ball in the night sky?
The blue snowball, you can just look for blue snowball in terms of where it is. It's in, oh shoot, I don't remember which constellation it's in. I know that when we saw it a few weeks ago, it was out over the city, like to the west. So that tells me it's higher in the sky in the fall. But
Gotcha.
honestly, I don't remember which constellation it's in. Someone will probably put that into the chat.
Yeah. I imagine that you do need, especially in the Chicago area, but almost definitely you need a telescope to observe this, right, Michelle?
Yes, absolutely.
I don't want people to go out there looking just with their eyes
No,
and
no, no,
hope
no.
to see that, because you're going to be disappointed.
Yeah, exactly. Here is another one, NGC 2392.
Ooh,
So this is a planetary nebula. The term planetary nebula came about from William Herschel, so the discoverer of the planet Uranus. He saw one of these. It had planetary features. Basically, it was round. It has nothing to do with planets. There may not be any planets there, but this is basically what's left after a star like our sun blows off its outer layers into space gently. It does not explode. So NGC 2392. I know that the Hubble Space Telescope has taken a picture of this object. So if you
very
want
cool.
to look that up, ours is not nearly as good as Hubble, but I'll be darned, it looks pretty darn good for one shot over Chicago. One image. This is not stacked or anything. So
Excellent.
it was pretty cool. Whoops.
Got folks saying that they've seen the blue snowball in 8-inch and 6-inch telescopes. So you don't need a huge telescope, but you do need a telescope.
Yes, that's right. That is right. Okay. All right. And let me go back to, let's see. Okay,
Excellent.
I'm good.
Are we going to take a look at some older images from the dome?
Yeah, let me go back to the slides and I'll go back to sharing
While
this.
you do that, we have one more question here.
Oh yeah, go ahead.
Somebody asks, during my volunteer days, we had guest view through the Coronado and the white light filter scope. What will guest view through now? Still the same telescopes. They're just not going to be attached. The Coronado is just not going to be attached to the 24-inch, but we still have those telescopes.
Yep.
And we will still be putting white light filter over the 6-inch and the 8-inch for solar observing. So there will still be plenty of solar observing. Do not worry.
Yep. It just won't, the solar observing just won't happen from the observatory itself.
Right.
We don't want to ruin our new telescope by pointing it anywhere near the sun. Even with the covers, it's still potentially dangerous to do that. So,
right. But we can have those telescopes right out front. So
absolutely.
It's all accessible.
Yep. All right. Ready for Mars?
Yeah.
All right. So this is
processed Mars.
So this was taken, now remember how I mentioned where Mars is, or Mars, when we took the image, the video a few weeks ago, Mars and Earth were like 100 million miles apart. They were a lot closer than that with this image here. So this was taken so you can actually see surface markings. This was with the prior telescope, the 24-inch or the 20-inch telescope. So, but you can see those lighter and darker shaded areas on the surface. And then we've got
stars.
Stars.
I gave it away.
It's okay. This is the Eagle Nebula, also called M16, the 16th fuzzy thing that Charles Messier made a list of. These are called the Pillars of Creation. You may remember that the Hubble Space Telescope looked at this piece right here, and then later on it added in more of the nebula. It's about 7,000 light years away, and baby stars are born here too. Pretty neat. All right, again,
it's kind of like a big space hand.
Kind of.
That's what I see.
Kinda. Yeah. Maybe a few fingers worth there.
Yeah.
That's a good way of thinking about it. And then many stars very far away. This is M81, the 81st fuzzy thing that Charles Messier put on his list. This is a spiral galaxy known as Bode's Galaxy. It's really pretty, right?
So pretty.
Yeah. This one is M51, the Whirlpool Galaxy. It's one of those few things in astronomy that actually looks like what it's named for, right?
Like a perfect little pinwheel.
And M104, the Sombrero Galaxy.
Beautiful.
Pretty awesome. Again, those were all taken with the 20-inch telescope. But the key to our new telescope is it's bigger. And that means those objects will be brighter through our bigger telescope. So we look forward to checking out all these as time goes on. So there we go.
Yes. Excellent. All right, so we usually share collections items as part of our shows and share interesting bits about the history of science or the skies. But today we want to share an interesting bit about the history of the Adler Planetarium and the Doan Observatory. So Michelle, when was the Doan Observatory originally built? How old is it?
Yes, 1977 is when it opened, August 4th, 1977. Even before then, it was... we knew that the Adler wanted to build an observatory for a long time. They even thought about putting it on the roof of the Adler, but realized that was not a good place to put an observatory. So we decided to build a separate building. So, all right, want me to share my screen so they can actually see a picture?
Yes, so we can see a picture of it.
Yes, being constructed.
Back in the day, yeah.
You gotta love the cars. Just check out the cars.
You can tell that it's an old picture from the cars.
Yeah. How many of those cars you see on like one of those auto auction shows that people pay a lot of money to see those cars today? Anyway, go ahead.
Excellent. So what was different about this observatory when it was built compared to now?
So the telescope originally in the observatory was one that was built at the Adler Planetarium itself. So that's the picture on the left, and that the mirror for that one was made at the Adler. It was a 16-inch wide mirror, and the telescope was basically made for the Adler. It was something that was made on site, and then. In 1987, the replacement telescope, so they decided to get a research grade telescope to replace it. And so that was the 20-inch telescope. And the manufacturer of that was DFM Engineering out of Colorado. So that's the picture that you see on the right.
Excellent. And like we mentioned, we recently got to be at the Doan Observatory for a new part of the Doan Observatory's history when we brought in the new 24-inch telescope. So we've got some images to share from that day. That thing that you see hanging in the sky is the very telescope that you just saw installed in the observatory, being held up by a crane so that it could be brought in. So in case you were wondering, how the heck we got these huge telescopes in and out of the observatory, you are not alone. The telescope was taken apart and pieces were lifted and taken in through the slit in the roof using a crane. So you can see in that picture on the left, that slit in the roof, and there's a little person there waiting to guide the telescope in through there. So it was crazy to see it all come together. We've got... You can see people bringing it in and pulling it in.
It was nerve-wracking to see our telescope that high in the air.
Yeah, it's kind of wild looking at these pictures, right? Everything was strapped up and we pulled it all down and pulled it together to lower and attach it. So Michelle, what do you remember about that day aside from how cool we all looked in hard hats?
Well, I remember that Adriana actually got to do a little bit of work helping to guide the telescope. So that was pretty cool. I was the one
Is
taking
that
some.
me? The
That's
picture's too
you.
small. I can't tell. Oh, look,
Yeah,
there
that's
I am.
you. That's you on the right-hand picture. That's Adriana on the left side of the picture, and the gentleman in the opening there, that is Matt from Planewave. So he was in charge of the installation, and this thing literally came in three pieces. It was that piece at the bottom with the that metal piece that attaches to the concrete pier, and then the L-shaped mount, which is kind of on its side for the picture on the right, and then the telescope came in. That's it. That's all it was, and
Yeah.
it was so neat to see it come together so fast.
Yeah.
That's the thing that I thought
Happened in
was
one
pretty
day,
amazing.
right?
Yeah.
Wild. So, just for fun, one more question for you, Michelle. What are you most excited about with this new telescope?
I'm just excited to try it out some more, get some new images, redo some of the pictures. Oh, wait a minute, hang on. I'm going to show. I missed showing the folks these pictures right here. There we go. So trying to redo some of the same images that were taken before, connecting with some of the objects in our collection, and taking some of those pictures. So to see something that may have been photographed 100 or more years ago, and taking our pictures now and comparing those. So it'll be a way to connect with people. So we hope
Yeah.
that we can get people to see the inside of the observatory when it's not snowing out like it is tonight, and connect that way, connect more online, and then someday we will get you guys in there so you can actually put your eyeball up to this thing too.
Yes, that is definitely something I am very excited for. We haven't had the opportunity to do real in-person public observing for a year now. So it's going to be so exciting to get to do it.
And Adriana has not been able to put her eyeball up to that telescope yet. It's just been me so far. So anyway,
it's going to be so exciting. I cannot wait. I will squeal in excitement. Okay, so we've got a couple of questions here. Why is it named the Doan Observatory?
Yeah, so it was named in memory of Ralph and Lillian Doan. So they were from the Chicago area. Lillian, in fact, is from my hometown of Minooka, Illinois. The family, Ralph made his fortune. He sold mailing label technology to Xerox, and so the family was blessed with a fortune that way. And so when Ralph and Lillian passed away, their children decided they wanted to give back to the nonprofit community in Chicago, and looked around for a partner. And they approached the Adler Planetarium and said, hey, is there a project that you all would like to do? And we said, hey, we got this idea for an observatory. And so they wanted to support the nonprofit community in Chicago. We wanted to bring even more of the universe to people and show people the sky through a bigger telescope, and our stars aligned, as it were. And so the Doan Observatory was built in the mid to latter 70s and opened in 1977.
Very cool. So somebody is asking about astrophotography.
Mm-hmm.
I have a telescope, a DSLR, and a tripod. I've been watching a lot of YouTube tutorials for beginners. Any tips that you can add? I know somebody commented that that Nick probably has some astrophotography tips in Skywatch Weekly, which I'm sure he does. Nick is an incredible astrophotographer. Anything else that you'd like to add, Michelle?
Yeah, so if you've got a DSLR, you can attach it to your telescope. You may have to look into maybe getting a C-mount for it. A C-mount would be specific to your DSLR and your telescope. So that is one thing you can do.
Is a C-mount like an adapter to connect?
Yeah, it's basically like an adapter. Yeah.
Gotcha.
Exactly.
Okay.
Yep.
Great.
And so it's the attachment method. Otherwise, there's no natural way for DSLR cameras to hook up to telescopes. So you have to get the adapter that way. And so you can also take pictures by just holding the shutter open of your DSLR camera, put it on your tripod, make it nice and stable, and you can get basically it's a plunger that or a button that can you can press it and it will hold the shutter open on your camera. And so some cameras you can set it for a certain period of time to leave it open. Others it'll stay open for as long as you press the button. Just depends on your model of camera. And so if you're able to hold the shutter open for 5 seconds, 10 seconds, you'll get some cool nighttime images of stars. So,
Steve says that it's a T-mount.
Oh, T-mount.
I don't actually.
Oh, yes, T-mount. Yes.
Thank you, Steve.
Wrong letter of the alphabet. Yes, T-mount.
Right idea.
Right idea. Wrong letter. Sorry, Steve. Thank you.
All right. So should we go ahead and chat about when people might be able to visit the dome, or how they can find out when they can visit the dome?
Yes. So we have this large telescope. For the most part, we want people to be able to look through it. That's why we're here. But we hope that we can get back to it when it is safe to do so. So look for information on our website, but you wanted to give people a little bit more information on that too, right?
Yeah. So I just wanted to mention that you can keep up to date with when the dome will be open by checking out the Dome Observatory page on our website periodically, and just have our friend Colleen, who is helping us out, post the link to that page in the chat. We hope to reopen for guests when we're able to reopen the Adler, so stay tuned.
Yep. In the meantime, we want to provide more opportunities online to be able to do this. If you guys can't be with us in person, don't worry. We got so excited taking some of these pictures and trying this out, at least getting ourselves set up to be able to show you the observatory tonight, which we couldn't do in person. But now that we have a pretty good idea of how we want to do it and what we want to do, and the fact that it's pretty easy to do, we can do more of this in the future. So stay tuned. So, but again, one thing to reiterate from what Adriana said, we'll open the observatory to the public to be on site when the Adler Planetarium opens. So, so that those will have to happen at the same time.
Yeah, so Beverly is asking, is that where you'll post info about live images? So the live images that we hope to continue to show from the dome are right now, until the Adler is open, going to be on Sky Observer's Hangouts episode. So the place to find that stuff is going to be on YouTube. We do a new show about every 2 weeks. So keep hanging out with us. We hope to actually come at you live from the dome next time, but this time we got thwarted.
We got snowed out. I mean, it is coming down in buckets downtown right now. So I'm sure Adriana can attest personally as to what the conditions look like near the
it's pretty bad.
It's pretty bad. Yeah. So it was not safe for us to be there tonight. So forgive us for not being able to do that. But yeah, we'll have to try it again sometime.
Yes, keep an eye out for future Live from the Dome episodes. So thank you guys for joining us and for learning about the Adler's Dome Observatory with us. Even though we couldn't be there, it was exciting for us to share some of these views from our observatory with you. If you guys find yourself looking up at the sky in the coming weeks, be sure to send us your photos and observations via our social media feeds using the hashtag #lookup. And thank you so much for joining us.
And tell us, we would love to know, how did we do? We'd love to get some feedback from you. Colleen is going to link a feedback survey in the chat. It will only take a very short time to fill it out. And if you filled it out before, if you're a fan of our show and you've heard us say this many times before, it is totally fine to fill it out again, because we can keep track of our improvements and our progress. So it will help make our shows even better. And you can send us suggestions for future show topics. And you will also get to it via a link in tonight's program description. So if you miss it in the chat, you can get it from the program description itself.
Yes. I know a couple of people have been asking about our Mars show. That's going to be on the 18th in just a couple of days at 1 p.m.
Yes.
Central, right, Michelle?
That's correct. Live on YouTube. So you'll be able to go to youtube.com/AdlerPlanetarium and you will see our Mars rover landing watch party from 1 to 3 p.m. There will be folks like me at the Adler. We will be broadcasting out, so don't come down. Stay safe. Watch from home. Yeah, we're gonna follow along as the Perseverance rover makes its way to the red planet Mars.
Very exciting. And beyond that, our next regular Sky Observers Hangout show will be on March 8th at 7 p.m. Central, our usual time. And we will be talking about the spring edition of Chicagohenge. So how to observe this interesting alignment in your own area, even if you're not in Chicago, during the spring equinox, and other structures and places made to align in interesting ways with the sun. So join us, and don't forget to subscribe to our YouTube channel as well. Thank you all for hanging out with us tonight. Thank you for being here. Stay safe, stay warm, and keep looking up. Good night, everyone.
Good night.